Okay, hello everybody. Yeah, Steve and I are part of the team that develops Vuo, which is a software tool for doing creative work. So today we're going to be showing you how you can use Vuo to make your own graphics, display them on a dome, and make them interactive. Can everybody hear me okay? Wait,
yes.
You're supposed to ask, can anyone not hear me? No, you're not supposed to ask that. Okay, let's just move on. First, I'd like to give you a sense of who Vuo is for and what it can do, which is easier to explain through examples, so we'll walk through a few of them. Okay, these images are by a graphic artist named Luis Andre Gama. These are still images that he started with photographs, and then he used Vuo to repeat parts of the image on top of itself. So, made something pretty cool looking. This next one was a performance by a group called Impact Theater. So they set up Vuo and a Kinect camera so that the performers could use gestures to paint colors on the screen. And this last one, this exhibit was a collaboration between a video person, an audio person, a dancer, and Paul Bohr, who made the dome itself. Yeah. So Paul used a spherical mirror setup so that they could make this inside-out dome where you could have hundreds of people looking at it from the outside. So they're actually projecting from inside of the dome. And he used Vuo on the software side to set that up. And that brings us to our topic for today, which is how you can use Vuo to make cool stuff for planetariums and other domes. We're going to cover a subset of that today. We're going to talk about how you can make your own graphics, how you can project onto a dome using a fisheye lens, how to react to audio and devices, and then how to record your graphics to a video. A few quick notes before we get started. Vuo runs on Mac OS, so if you have a Mac, congratulations. If you have Windows, we do plan to support it eventually, but we do not yet. Sorry. Second, we'll be demonstrating Vuo version 2.0, which is not yet released. It's coming out later this year. So if you go download Vuo right now and it looks different from what you're seeing, hey, that says 1.3. Okay, it's actually 2.0. If it looks different from what you're seeing today, that's why it's a different version. And finally, we are making a recording of this workshop. I guess the immersive folks are also recording it. We're going to put our recording up on the Vuo YouTube channel, so in case you miss anything today, then you can rewatch it. If for some reason you do not want to be recorded, just let us know. Okay, so now we'll move on to sort of a tutorial. So first up, how do you make graphics with Vuo? Today we're going to be talking about 3D graphics. So a good starting point for that is to go to File, New Composition from Template, and then Scene. Okay. So this thing, what you're seeing here is a composition. A composition is just a word for a thing that you build in Vuo. A composition is a computer program. So this stuff in the main part of the window, this is the instructions or the blueprint for what the program is supposed to do. And then if you click the run button, then you see what it actually does. Ta-da! So yeah, this doesn't do a whole lot yet. All it does really is display a window. That comes from this thing that says render scene to window. So these rectangle things that you see, those are called nodes. Nodes are the building blocks of Vuo. So each node has a specific job that it does, which is written across the top of it. And then if you click on the node, then in that panel, then you can see more information about the job that it does. Okay, so our window's looking pretty empty, so let's add something to it. The area along the left side of the window is called your node library, and that is where you go to find more nodes to put in your composition. So we're going to find a 3D shape that we can put into our scene. Okay, and Steve's going to pick a torus, which is a donut shape, and he's going to connect it to other nodes so that it will appear in the window. And there it is. Oh. Is that a really tall, skinny window right there? Okay, yeah, that's a really tall, skinny window right there. Okay. Okay, so yeah, let's look at what he just did. So Steve drew a line, which is called a cable, to connect the make torus node to the render scene for window node. So it's kind of like, oh, you can't even see it. I was going to use an analogy. It's kind of like this cable here that I will try not to unplug that's connecting the computer to the projector. So the computer is in charge of making the image, and then it sends it through the cable, and then it pops up on the projector. So it's kind of the same idea in Vuo. So the make torus node is in charge of making the shape, and then it sends it through the cable to render scene window. So Steve also drew another cable on the other side of make torus, which I'm going to hold off on talking about for a minute because we're going to change it. The circles, these little circles along the left side of the node are called ports. Ports control the settings of the node. So for example, if you wanted to change the thickness of the torus, then you would just double click on the port and edit it. Okay. Right now, our torus is sitting right in the middle of our tall, skinny window. So the torus's position and rotation and size are all controlled by this transfer port. Instead of having the torus sit in one place, let's actually have the mouse move it. So we'll have our first bit of interactivity. So Steve's going to set that up, and then I will explain it. Oh, that's good. Thank you. Okay, so how does this work? First, a little background on 3D space with our visual aid here. Okay, in Vuo, 3D space is divided along 3 axes. So your x-axis goes left and right, your y-axis goes up and down, and your z-axis goes front and back. So if you want to say where an object is located in 3D space in Vuo, then you would say it in terms of the x, y, and z axes. So it's like plotting points in an algebra class. So, can you put the torus back in the middle where it was, just for a minute? It's our little workaround because it's our version in progress. It's not released yet. Got it? Okay. Okay, right now the torus is sitting in the middle of the window. It's at the intersection of the 3 axes at a point called 0, 0, 0. We can change that, by editing the translation, so we can move it along the x-axis by changing the first number, or the y-axis by changing the second number. Okay, and then if we hook up the mouse again, okay, then you can see that the mouse is providing those x and y coordinates. Okay. Let's add another object into our scene. So The obvious thing to pair with a donut would be a stegosaurus. Okay, so what we have here is a 3D model that was created in Blender or some other 3D modeling app that we downloaded. So we're going to add that into our scene. So Steve has the 3D model file, and he just dropped it onto the canvas to create a fetch scene node. And he's connecting some cables, so he's using allow first event so that it will import the 3D model just one time instead of repeatedly. And he's got another cable taking it to render scene to window. Okay, so we've got our little stegosaurus there. Okay, and one more thing, just for fun, let's make this a spinning stegosaurus. So if you want to animate something in Vuo, a good node to use for that is fire on display refresh. Yep, which we happen to already have here. So if you remember when we had received mouse moves hooked up, that one was sending out the position of the mouse every time you move the mouse. So fire on display refresh, instead, it's going to send out the number at a steady rate of 60 times a second. And that number is the number of seconds that the composition has been running. So what we can do is we can use that number as the degrees of rotation to rotate the stegosaurus. Oh, yeah. Okay, so now it's rotating very slowly, and we can use a change speed node to speed that up. So it'll just multiply the number, so it'll go faster. There we go. So there's our spinning space. Okay, so that was a crash course on how to make 3D graphics in Vuo. So now, how do you put them on a dome? Well, in real life, if you wanted to film something for a dome, you would go out and you would take a video. So for example, if you had a hemispherical dome and you had a fisheye lens projector in the center, you could go out and film using a camera with a fisheye lens. Well, in Vuo, it is the same idea, except that instead of a real scene, you're filming a virtual scene. Right now, what you're seeing here in this composition is like the virtual scene is being filmed by a camera, not a fisheye camera, just a regular one, that is positioned right here, a little bit in front of the scene. And we can actually move that camera around by dragging the mouse because this composition has a big draggable camera. Yep. So this regular camera is good for displaying on a flat screen, but of course if we wanted to put the stegosaurus up on a dome, then it would be all warped. So what we want to do is replace the regular camera with a fisheye camera. Vuo has two nodes for making a fisheye camera. The only difference is how you specify the orientation of the camera. So we'll pick make targeted fisheye camera. And Steve's going to hook that up so we can see what it looks like. Okay, so now our scene looks kind of warped on the flat screen, but it would look right if you projected it onto a dome. So,
sorry.
Yeah, okay. So let's go through the input ports of make targeted fisheye camera to make sure you understand that. Okay, so the first one is name. That doesn't really matter here. That's if you had multiple cameras that were looking at the scene and you wanted to switch between them. Position is where the camera is located. So Steve actually zoomed in a little bit, so it's right here in front of 0, 0, 0. Woo. Okay, and then target is the direction that the camera is pointing. So you can think of the camera as having a straight line coming out in front of it, and target is a point on that line. So the way we have it is it's sitting here and it's looking back along the z-axis.
It's all radians.
It's a vector. So target, we're saying 0, 0, negative 1, so that's like this point right here. So it's looking from here back this direction. Okay, up direction is the way that the camera is rotated. So right now it's right side up and not tilted at all. Field of view, oh, you're going to tilt it? Okay. Okay, field of view, you probably want to just keep it at 180 degrees for a hemispherical dome. Vignette width and sharpness, those control the fade out along the base of the dome, which is the circular edge of the image. Okay, Steve and I have used the fisheye camera, Vuo's fisheye camera, in a hemispherical dome that had a single fisheye lens projector in the center. And we have also used it in a dome that had a 6 projector system, but it had its own software that would take a single fisheye image and split it up appropriately between the projectors. But if you are working with a setup where a fisheye image is not the right thing, so for example, you have one or more spherical mirrors, then there's a different node you want to use for that, which is work image with projection mesh. And I'm not going to get into it today, but if you click on the node in the node library, there's documentation and an example and Paul name to help you get started. Okay, I want to cover 2 other things briefly. One is how to save your graphics to a video, and the other is the different kinds of interactivity that you can do in Vuo besides using a mouse. Okay, so interactivity. If you type receive into the node library, then you can see all the different devices and protocols that Vuo can receive input from so that you can use them to interact with your composition. If you ever have live musicians performing in your dome, like folks were talking about in the previous session, receive live audio is a good one for that. So we'll do a quick demo. So receive live audio, you can make your graphics react in real time to the music. There are different aspects of the music that you can react to, but we could just, a simple one is just the loudness of the music at any moment. Yep, so this, well, what he just did with the mixed samples is just saying you have like maybe a left and right channel bringing in audio, and that's going to combine the both together. And then calculate loudness is going to give you the loudness of the audio at any given moment as a number between 0 and 1. So like if you have music with a heavy beat, that's going to go like poo, 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 poo. So what can we do with that? We can use that number, we can hook it up with a cable to some other node that's going to affect the graphics. So for example, we could use an explosion. Yeah, explode 3D object, and use that to explode our stegosaurus model a little bit. in time with the music or according to the loudness of the sound. Okay, so that's a little taste of interaction in Vuo, and if you have more questions about different ways you can interact, I think we'll have plenty of time for questions at the end. Last thing I want to mention is how to save a composition to video. So you might want to do this if you're making a pre-rendered show, or if you want maybe to make a little video that you can share on social media to advertise a dome show. So there are different ways of doing this in Vuo. The easiest is just go to File, Start Recording. And then that's just going to record the contents of your window until you go up to File, Stop Recording. So that's pretty straightforward. And I won't go into this now, but just to let you know, there are other methods that you can use if you want to record a video that has audio, because this one's just the graphics. Or if you have graphics that are too heavy to render in real time, especially if you're doing something 4K or 8K and maybe your computer can't handle that. Okay, so just a quick review. Today we covered how to make graphics with Vuo, how to project them onto a dome using a fisheye lens, how to make them interactive with a mouse or audio, and how to save them to a video. Okay, so what questions do you have?
Do you have Siphon support in Vuo yet?
Yep.
Awesome.
Yeah, you can take Siphon. So Siphon is an application, a protocol. It's a thing that you can use to send video in between different applications on a Mac. And so you can take Siphon video in to Vuo, and you can send Siphon video out if you want to send it to a different application. Yes?
Do you think you develop a Windows version?
Sorry, you said?
Do you think that you could make a Windows 10 version? Or is only on Mac?
We would like to make a Windows version. We have been planning that for a long time, so we don't have a date for that, but it's something that we would like to do one of these years. Yeah.
So this comes from some student projects, one in particular. Do you see any need, or maybe if you have support for using polar and hemispheric coordinates instead of Cartesian coordinates? I had one student, for example, he wrote all the code from the ground up. It's crazy, but he did all the math for hemispheric, so he could compute distance between graphics and speakers, so he could drive the speakers proportionally, actually square proportion to the distance. Yeah, so he did all that in hemispheric coordinates.
Oh, okay.
Do you see much utility for that, or?
I think you're not the first person to ask about that. We have a, well, yeah, you can do the conversion in Vuo using math, but I mean, I can understand that's kind of a pain if you have to do it over and over again. Do you have a feature request for that?
I don't know.
Well, I imagine you can make a library out. I mean, it doesn't sound like that would be very hard.
Yeah, I mean, yeah, it's something that you could do or a student of yours could do. Or we take feature requests from people, and then like anyone who has Vuo can vote on what they want to see for their features. I mean, what they want us to implement next.
And the other question I had to do with how many cables we should run to the video artists in the planetarium as we're doing upgrades. So right now I would guess live audio is stereo. Is it strapped to that or not? So the real question is, if we're driving 10 speakers, should we give 10 audio signals to the VJs?
Oh.
I'm not sure
Yeah.
what we do with them, but you know.
Yeah, well, so we have actually performed using Vuo in Dale's planetarium. So what did we do for that?
One example, there was a marimba player in the dome, and we had set up a microphone close to the marimba and used that to feed into Vuo's receive line audio node. In that case, we just had that single microphone, so it was a monophonic input.
Right.
Although Vuo, it supports however many inputs and outputs your audio system supports. So in the receive live audio node, the receive channels is a list that can contain an arbitrary number of channels. So whatever your audio system gives it.
Okay, so that's cool. So it's not so much a tools question as a creative question of
Yes.
what the hell do you do with it once you have it, right?
Yeah.
Yeah.
However the visualist wants to make use of that data.
Thank you.
Yeah.
Is there like a plugin system where users will be able to code their own nodes or modifications to the system?
Yes. There are actually two ways that you can do that. At least two. One is that you can make what's called a subcomposition. So it's like just a composition that's shareable, and you can use it as a node. So that's coded in the Vuo language, and we also have a C++ SDK that you can use.
Right. And also, do you support NDI for transferring the video between computers? It's, I guess, works kind of similar to Siphon, but it's over a network.
Yeah, we don't
Not
yet.
yet.
NDI is Windows only, I think.
No, it's on that also.
Oh, okay.
Not yet, but it's on the list soon. Hopefully.
Soon, hopefully. Is that all your questions? Okay. Valen, do we have time for any more questions?
Yeah, you guys, you can go long if you need.
Okay.
I'm next, but we originally had 30 minutes per person, and we had an hour and a half slot. And it looks like one of our people is not showing up, so.
Okay, yes.
Do people ask about something like graphical selection, like point in some direction and then the graphic system would determine which object was being pointed at? I'm not sure what the mechanism would be for doing it in a dome, but is that something that you try to support somehow?
Well, I guess there are two pieces of that. One would be, how do you do the pointing? Like you have some kind of a, well, like Steve did a demonstration at IMERSA last year where he set up so that he could use his iPhone as a pointing device. So that's part one, is what do you use to do the pointing? And I guess another option would be skeletal tracking. So if you had a Kinect camera set up, then it could track where you're pointing. Then the other, or leap motion, yeah. And then the other piece of that would be, how do you know which object you're pointing at? What do we have for that?
With layers, there's like is point within layer.
Okay.
There's not an input on the constraining objects yet, but that's.
Yeah. So yeah, you kind of have to do your own calculations at this point to see, like, you know, you would know which point you'd be able to map from your device to some point on the dome or on the screen, and then you'd have to do some kind of calculations within your composition to figure out which object you're actually hitting at that point, if any. Does that make sense?
I guess so. I mean, I could ask separately. I mean, it's probably not something I would be trying to do, but I could imagine people wanting to do that somehow. And you don't want to code like low-level picking calculations in every piece of code, but if there were like a way to do a vector array intersection with each of a bunch of objects and have some of them say yes, then that would be enough.
Yeah, that would be cool.
On a generic basis, in all game engines, what you do in order to accommodate that is cast a ray from the camera source location towards whatever direction you're having them point. And then you can make an indicator that rotates on that vector of rotation to indicate to the user what their heading is. Yeah, and that works in any presentation format, like not just domes, but also in flat screen format and anything where you have a single source component for the video. And not all video ends up being from the same source. Like you might have orthographic cameras that are all combined, that combine a strip of images that you're animating. And that is a really valid way of providing interaction too. And in those cases, you use relative movement on each of the points for all of the movement areas. Line games in Disney are often made that way.
With a bunch of flat cameras.
Yeah, a series of flat cameras, and your interaction is all relative to your previous location, as opposed to your relative location on your phone movement or whatever.
Okay.
Yeah.
Thanks.
Yeah, no problem.
So, yeah, I was going to say we'll write that down, but it's on the video. So, and one of the reasons that we're here is to try to find out like what people actually need. Because I mean, we build the software for other people to do interesting things with it. So, yeah, it's really helpful for us to find out what would be useful that's missing. So, thank you. Any other questions? Okay.
Okay. Well, thank you so much.